Hey guys, welcome to the active transport video. Just like the last two videos, you're going to watch it. You are going to take notes, whether it's written or verbal. Pause or rewind as you need, and you will have an interest quiz over this the next school day. Alright, so in the last video we talked about passive transport, and as you can see on the video with the panda, passive transport moves from high to low. You can see that as he's sliding down, he's not using energy, just like passive transport doesn't use energy. And of course, it's going high to low or down the concentration gradient. So now today we're going to talk about active transport. So active transport is literally the complete opposite of passive transport. Active transport does use energy. So I want you to look at this lady right here on this escalator. Yes, she looks very stupid. I'm pretty sure some of y'all had tried that also. Anyways, so she's walking up this elevator and she's going from where? She's going from low to high. Now, as she's climbing up, is she using energy? Yes, she's using a lot of energy to try to get there to the top. So, and because she's using energy to get there, she's going against the gradient, against it. You can see that the gradient is going down, but she's going up, so she's going against it. So active transport moves from low to high or against the concentration gradient. Again, active transport moves from low to high or against the concentration gradient. And because it moves against it, she is using energy, or active transport does use energy. Okay, so the word energy, of course, there's another name for it, ATP. So some of y'all were like, what the heck does ATP stand for? Maybe you didn't ask that, but you know I'm going to act like you did because y'all are scholars. But ATP stands for adenosine triphosphate. ATP. ATP. Now, if you look right here, I want you to look at this diagram. It's going from low to high. And as it's going from low to high, look at what it needs every time. Boom, energy, boom, energy, boom. So it needs that ATP in order for it to pass. Look right here. The energy is going to come, bam, the red, and now it can pass through. So nothing can pass in active transport until energy is expended to that protein. Just like active transport, there are three kinds. You have protein pump, endocytosis, and exocytosis. Protein pump, hey, endocytosis and exocytosis. All right, so those are the three types of active transport. If you look right here, obviously, what does the protein pump need? Proteins and ATP. If you say ATP, you are also right. So if you look right here, you're going from low to high, and you need ATP, and of course, it's also using a protein. Endocytosis and exo, you look right here, the endocytosis, you see a whole bunch of molecules going in, and then it's going to take a piece, it's going to like fold and go here, and the exocytosis is exiting. So we're going to go a little bit more into all that. So here is protein pump. It is y'all see the little, okay. The protein pump, it moves like ions and other stuff that can't pass on their own. And of course, because it's active, it moves from low to high. And of course, what is it using again? ATP and proteins. That's why it's called protein pump. So I know this is kind of nasty, and I put this video for a reason. When I need y'all to like get this in your mind. Whenever you hear the word pump, I think of something, maybe not me, but you might think of something active. It's active, okay, right? Like fist pumping, yeah. Fist pumping. So we're fist pumping. This pumping, I need energy, and I'm active. Okay? So I put this little kid here so you can see he's like, ooh, you know, he's getting it. Yes. So think of this as protein pump. Whenever you hear that word pump, pumping, pumps, I don't care what is pumping. You be like, oh, that's active transport, and it's using energy. All right, so what about really large molecules? Like we looked at things like that. So I want you to watch this video. This right here is an amoeba, and this is a bacteria. Watch what happens. Oh, you got that, boy. Okay, so notice how in the video, actually that's white blood cell, my bad. But notice how he like wrapped himself around and engulfed it. So if you remember that Amoeba Sisters video, she had the cake and she like, if you watched that one, yeah. So it's the same. This is so when we're trying to get large molecules in the cell or out the cell, it's not going to do it one at a time. No. The cell is smart that it's like we want to do it in bulks. It's like going to Sam's. We're not going to buy just one box of cereal. We're going to get a bulk of it. Or we're not going to throw away this one piece of trash. We're going to get all our trash in one bag and then we're going to throw it out. So if you look at the video right here, endo, it takes it in. The cell membrane folds around it and it comes inside the cell. If you look at this one, we see that this vesicle is moving, fuses with the cell, and lets it out. So, exocytosis, the word exo, what does it sound like? Exit. So, something is leaving out of the cell. And basically, it's a process of where materials or bulk of materials or large material is expelled. So, if you get expelled from school, what does that mean? Yes, you get kicked out, and that better not happen to you. So they're kicking out the stuff that they don't need anymore. So look at the diagram. We know it's exo because the arrow is showing how this vesicle is moving out. Now endocytosis, the word endo sounds like what? Enter, into, in. So that's what that means. You're taking it, a bulk of material or a large material in. So here is, I don't know, let's say the bacteria, and it takes it in, and you can tell because the arrow is pointing in. So it's importing material. So just to give you a little overview, combining what we learned about passive and active. So this first one is showing regular diffusion. We know because it's molecules going from high to low or down the gradient, and that's how we know that it's passive. And because it's not using a protein, that's how we know it's regular diffusion. Now, let's say this molecule right here was water. What would it be then? That's right. It'll be osmosis. All right, so the next one you see with the protein is facilitated diffusion. Because again, we see it's high to low, but because it's using a protein and no energy, it's facilitated. Now, what about this one that has ATP? What is that one called? That's right. Active transport of the protein pump. Awesome job, guys, because it's going from low to high and it needs ATP. So I want you to write this question down and answer it on your notes. How does a protein pump act like a toll booth? Write your answer down. I want to see if we're on the same page, because like I'm your teacher, you're my student, and I want to see if we like flow in the same wavelengths through this screen. All right, now the last thing before you come off this video, I want to see if you can answer these questions without looking at your notes. So flip your notes over, put them away. Don't be cheating, because I know you're cheating. Even though I'm not like right by you, I know you're cheating if you look. All right, question 1. What direction does active transport molecules move? 2. Does this process take any energy? And 3. What pumps the molecules into the cell? Hopefully you can answer those 3 questions on your own. Good job for making it through another video. Please let me know in the comments below. I feel like a YouTuber. Please let me know in the comments below if this video helped you and if you had any questions at all, so that I can make sure to answer them. Adios, mi diablo feos, and I will see you soon at the next video. Bye.